Okay, in the external communication interface, basically as the name itself indicates, it is this type of communication is used to communicate between the embedded device and the external components, whichever we are going to use. So the first type of technique, it is through RS-232 cable. It is RS-232C and RS-485. These are the two types of cable which is basically used to communicate from the embedded devices to the other devices. Maybe to a system it can be connected, or maybe to a printer the device can be connected, like that. So what is this RS-232 cable? RS-232, it is nothing but full duplex, okay, where transmission as well as receiving both are possible. Wired, it is a wired type of communication, and asynchronous serial communication interface. Okay, it is a full duplex, wired, asynchronous serial type of communication. You might have seen this as ports which may you have used in some of the labs, say DB9 connectors, as well as DB25 pin connect. 25 indicates the number of pins here, 9 indicates the number of pins here. We call it as DB9 connectors as well as DB25 connect, 25 pin connectors. So basically this RS-232, it is nothing but the extension of UART communication. In the previous class, we have seen UART, universal asynchronous receiver and transmitter, right? It is extension of this. Along with this, we have various acknowledgement signal along with the two pins, that is transmission and receiving pin. Okay, we have TX as well as RX pin over here. Along with that, there are various control signals or the acknowledgement signal generated in this RS-232 cable. So basically, UART uses TTL logic, whereas RS-232, it uses EIA standard for bit transmission. It is based on the voltage level over here. Okay, RS-232 interface define various handshaking signals. This is very important characteristic. It defines various handshaking and control signals for the communication part from the transmit as well as receive signal for the data communication. So as I told you, basically this RS-232 supports two types of connectors, the DB9 connector, which is 9-pin connector, and DB25 connector, which is 25-pin connector. Okay. So we'll just go through what is this DB9 connector and the function of DB9 connector, how exactly the communication is established. So you can observe here, this external communication interface, DB9 connector, the function of various pins are given in this particular table. Okay, so pin number 3 and pin number 2, it is nothing but TXD and RXD. Okay, TXD indicates transmit pin used for transmitting serial data, whereas RXD indicates it is receive pin used for receiving the serial data. So basically this is transmission as well as receiving, where the data will be transmitted or received serially. Okay, along with this TX and RXD pin, there are various control signals, or what we say the handshaking signals required for the communication purpose. Okay, the first type, it is nothing but pin number 7. It is request to send, RTA signal. We call it as RTA signal. Pin number 8, it is CTS, clear to send. So we will go through the functions and the steps followed in the communication. So the first step, so say RS-232, it is point-to-point communication interface. Okay, and the device involved in RS-232 are called data terminal equipment and data communication equipment. Remember, it is the point-to-point. Point-to-point in the sense, basically I'll have two devices. Okay, I will name the device as device 1 and device 2. Imagine two devices as device 1 and device 2. Now I want to establish a communication between device 1 and device 2 through RS-232. So device 1, basically, which establishes the communication, we call it as data terminal equipment. Okay, we call it as DTE, data terminal equipment, and the second device as data communication equipment, where the communication need to be transferred. Okay, DTE and DCE. Now, if no data flow control is required, in the sense, say I don't require any acknowledgement signals or any handshaking signals, in such type of cases where only transmission and receiving of the data is sufficient, so in that cases we are going to use only TXD, RXD signal lines and the ground lines. Okay, you can observe in the previous table, TXD pin number 3, pin number 2, as well as pin number 5. Okay, these pins will be used. There will be no control signals, nothing. Okay, the RXD pin of DCE, this is like, say, how the connections are done. The RXD pin of DC, that is data one device, should be connected to the TXD pin of DTE and vice versa, TXD to the RXD. Okay, that is how the communications are done. Now suppose say that if we require the control signals or if we require the flow control for the serial transmission, then these are the steps involved. That is, say, step number 1, okay, that is request to send. Okay, first step, it is like request to send. It generates the RTO signal first. Okay, the DTE equipment. Remember, I'm talking about DTE, the device one. DTE equipment, if it has some data to transfer, before sending the data, an handshaking signal, that is nothing but ready to send, will be generated. Okay, so here pin number 7, this RTS signal will be generated by the first device, and it will be transferred to the second device, which is nothing but data communication equipment, DCE. Okay, and after receiving the ready to send and clear to send signals, coordinate with data communication and DCE. That is nothing but once RTS signal is sent by the data terminal equipment, for that an acknowledgement will be sent back from the data communication equipment, that is from device 2. That acknowledgement signal is known as clear to send, CTS signal. So these are the first step. First, RTS signal will be sent from device 1. In response to that, a CTS signal clear to send will be given back by the second device. Okay, so this is the first step. Well, after receiving the CTS signal, whenever the DTS DTE, that is first device, has a data to send, it activates RTS line, and if DCE, that is second device, data communication equipment, it is ready to accept the data, it activates CTS line. So here the communication link has been established. Okay, the next step, the data terminal ready DTR signal is activated by DTE. Okay, once you receive the CTS signal, next we need to activate the terminal. Okay, so for that purpose, DTR signal will be generated by the first device, data terminal ready, when it is ready to accept the data. Okay, and the data set ready is activated by the DC, that is second device, when it is ready for establishing a communication link. Okay, now DTR should be in the activated state before activation of DSR. So this is second step. First one is RTS and CTS, ready to send and clear to send. Once CTS is received, data terminal, that is device 1, will activate data terminal ready, and device 2 will activate data set ready. Okay, after this activation, a link is established and data carrier detect. Okay, some carrier signal should be there in order to transfer the data. So DCD signal, data carrier detect, is used by the second device, data communication equipment, to indicate that DTE has a good signal is being received. Okay, then after ring indicator is nothing but a modern specific signal line for indicating that incoming data, incoming whatever call or whatever is it, just for an indicator. After this handshaking signal, then only the transmission will take place. Okay, this is about RS-232 DB9 connector. Basically, RS-232 DB9, it is a wired connector used for the full duplex communication, which is asynchronous as well as serial communication interface. As I told you, there are two types of connector, DB9, which is most famous, DB9 type of connector, as well as DB25 pin connector. So in this, again, we have an option. These DB9 connectors, it can transfer the data with the flow control, that is with the handshaking signals, or else without the handshaking signal, whatever it is. If handshaking signals are required, these are the functions of each pins given. Okay, TXDRX is basically for transmission and receiving. CTS is, RTS is ready to send, CTS clear to send, DSR is data set ready, ground pin, DCD is data carrier detect, DTR is data terminal ready, and ring indicator. So there are certain steps followed before the data have been transferred. Once this handshaking signals are given, then only a link will be established between device 1, that is data terminal equipment, and the device 2, that is data communication equipment. And once handshaking signals are complete, then the data transfer will take place. Okay, this is about RS-232 connector. Next type of communication from device to device, that is from embedded device to the external device, is nothing but very familiar type one, that is USB, Universal Serial Bus. Okay, in this USB, Universal Serial Bus, it is also a wired high-speed serial bus for data communication, right? So many applications you might have observed, like you can connect a mouse to a device, or you can connect a printer through the USB device, or you can connect a memory chip through the USB, or you can connect a printer, various different types of external devices like fingerprint scanner, so many devices can be connected. So basically in all this topology, if you observe, okay, the USB communication follows a star topology, right? It is with the USB host. We'll have a main host, say for example, desktop, if you consider it may be a main host for which various devices will be connected. So basically it follows a star topology, USB host at the center, and one or more USB peripheral devices host connected to it, right? You can observe this particular diagram. USB host, which is nothing but the hub. Through this hub, various peripheral devices through the USB it can be connected, and it can be controlled through this hub. Okay, the USB host can support a connections up to 127 devices, including slave peripheral devices and other USB hosts. It can support some other USB hosts also. Okay, USB transmits data in the packet format. Each data packet has a standard format. Okay, the communication is a host initiated one. The host will once a device is been connected, host will install the required device drivers, and it is the one which controls all the other like data transfer techniques, or how it has to be, what is the data rate, everything will be controlled by the host. Okay, so basically this host contains USB host contains a host controller which is responsible for controlling the data communication, including establishing connectivity with USB slave devices, packetizing and formatting the data packet. Okay, all these are the responsibility of the host device. There are different standards for implementing the USB host control, say namely open host control interface and universal host control interface. All those are the different techniques, different protocols followed. Based on this protocol followed, one will decide what is the data rate, how the packet is done, how the packetization, what should be the start bit, what should be the end bit. Everything will be decided through this particular protocol, and everything will be controlled by the host. Okay, so if I get into the hardware section, that is pin configuration of this USB device, if you just check any of the USB device a connector, basically there will be 4 lines, right? 4 pins will be there. You can observe here pin number 1 to pin number 4. So pin number 1, it is nothing but V bus, sorry, which carries power. Okay, the first one, pin number 1 is V bus, which carries a power, that is say power around 5 volt. Second and third pin, which is named as D minus and D plus, which is nothing but differential data carrier line. So through this 2 pins, that is the differential data carrier lines, D plus and D minus, the data will be transferred with the opposite polarity, say positive as well as the negative. The data will be transferred. Basically, why this differential carrier line is required is in order to suppress the noise signals. Okay, in order to remove the noise signal during the transmission, these differential carrier lines are used. Basically, it transfers the data signal. And the last pin, pin number 4, it is ground signal. Okay. So this is about the USB connector. So each USB connectors will have its own ID. We call it as a product ID and a vendor ID, VID. PID and VID, each devices will have its own ID. Okay, this PID and VID are embedded to the USB. It is embedded to the USB chip by the USB device manufacturer. So like different USBs will be connected to the different devices. So it will have its own ID. Based on that ID, the device drivers will be installed. The VID for a device is supplied by the USB standard forum, and PID and VID are essential for loading the drivers corresponding to the USB drive device for the communication. Right? Say for example, you have a USB which is connected to the keyboard, and that keyboard you'll be connecting to a system. So whenever I connect a keyboard, right, the device driver of that keyboard should be run. Right, that particular application should be run. So how is that possible? So each device, each USB devices will have its own PIDs, product IDs, and based on that, the applications will be picked and it will be executed. So this is about the USB. So basically this USB, it is again a wire type, and it is nothing but it follows the star topology, and along around nearly around 127 different devices can be used, which is very high speed serial type of bus communication, right? So basically it contains 4 lines. First one is to carry the power, and the last one is for the ground. Second pin and second as well as the third pin, it is nothing but differential data carrier lines which carries the data signals. So this is the second type of data communication, communicating between the embedded device and the external world. Okay, that is USB device. The next one, the next type is nothing but what we call a Firewire, or we call it as IEEE 1394. Okay, in general, say Firewire. You might have observed this in various connectors. These connectors are being used to connect one device to the other device, where the data transfer rate was very high in this compared to your USB or the previous techniques, whatever we have studied. Okay, it is also a wired isosynchronous high-speed serial bus communication. Okay, it is also known as high performance serial bus communication. Okay, it supports peer-to-peer connection and also point-to-point, and also it can support point-to multi-point connections, allowing 63 devices to be connected on the bus in a tree topology. Okay, it follows basically a tree topology kind of things. Like basically, I'll have a host. Through that particular host, various these fire wires can be connected. And we can observe here, this supports around a data rate of 400 to 3200 Mbps rate, that is bits per second. So sorry, the data rate is very high in this case. The transfer rate is very high. So it uses here also same thing. It uses differential data transfer. Okay, two different signals, two different carrier signals are used to transfer the data, and interface the cable support three types of connectors. Namely, we have 4-pin connector, we have 6-pin connector, as well as we have 9-pin connector. The 6-pin connector we call it as alpha connector, and this 9-pin connector we call it as beta connector. There is nothing but the number of pins present here. Okay, each pins will have its own functions, as like say handshaking signals and all. We'll see that the 6 and 9-pin connectors, the main difference between this 4-pin, 6-pin and 9-pin, the 6 and 9-pin connector, along with the data carrier signals, it has the power lines also. Okay, it carry powers also to support external devices. In suppose your external device requires any power in order to operate, so the power will be carried through this wire itself. It doesn't require an external power. That is only with respect to pin number. It is alpha connector, 6-pin connector, as well as a 9-pin connector. Okay, it can supply unregulated power in the range of 24 to 30 volt. Okay, a voltage of 24 to 30 volt can be supplied through this pin. So these are the various functions of these connectors. As I told you, there are three types of Firewire. One is 4-pin connector, 6-pin connector, and the 9-pin connector. In the 4-pin connector, you can observe pin number 1, pin number 2, pin number 3. Pin number 1 is named as TB minus, TPB minus, and TPB plus, TPA minus, and TPB. These are nothing but differential signal lines for signal line B, and differential signal line. All the first two is for signal line B, and the second two is for signal line A. This is the differential signals being transmitted. It is nothing but you can consider it as a receive pin and transfer pin. Okay, say one at device 1, if you want to transfer a data from device 1 to device 2. So device 1, I can consider, if I assume the device 1 transfer pin is TPB, okay, that is signal line B, and at the device 2, it will be connected to TPA, that is signal line A. So similarly, vice versa. Okay, so basically transmission and receiving both can be done at a time. Okay, so for that purpose, you will have two different signals, two different signal lines, signal line B as well as signal line A. In USB, if we consider that full duplex transmitting at a time, transmission and receiving at a time is not possible, because we have a single differential line, right? Only one differential line is there. So either you can transfer or either you can receive. Both is not possible. But whereas here I have two different lines in this Firewire, so both uploading as well as downloading, that is transferring as well as receiving, are possible in this particular wire, that is Firewire. Okay, so if I consider pin number 6-pin connector, here you can observe along with this signal B, signal line B and signal line B A, so you have two more pins. Okay, that is power as well as ground pin. As I told you, this particular pin connectors can carry the power to the external devices also. Along with that, a ground pin is also there. If we consider 9-pin connector, power as well as ground pin, along with that, we have three different connections, that is TPA and TPB, which indicates it is a shield for the differential signal line. Normally it is grounded, and TPB is a shield for the differential signal line B. Okay, which acts like a what we call as protecting signals or which will protect the data signals which have been carried through a particular line, signal line A or signal line B. Okay, NC is the last pin, that is there is no connection. So this is basically the functions of each pin connectors. Uh, Along with that, IEEE connectors contains, that is what I told you, it contains two differential data transfer lines, line A as well as line B. Okay, and everything have explained you can find this particular connectors especially in digital camera or the cam recorder scanners and all. If you observe the connectors present in that cam recorder, some one point it will be which will be connected to the system, basically it will be a USB, but to the the connector which has been connected to the scanner, you basically will find this Firewire type of connectors. Okay, so where the data rate will be very high. Different types, as I told you, three different types are based on our application. Any connectors can be used. Okay, so this is about the Firewire connector, the third type of connector, Firewire connector. The next type of connector, very simple connector, it is IRDA, which is nothing but infrared communication. Here it is a serial type of communication, serial half duplex. Okay, line of sight based wireless technology. It is line of half duplex, in the sense either transfer or receive. Line of sight based wireless line of sight in the sense there should be the line of sight between the transmitting as well as the receiving section. There should be no what we call any disturbance in between, right? There should be a straight line of communication, no components or nothing should be there in between the communication. Okay, infrared communication technique make use of infrared waves of electromagnetic spectrum for transmitting the data. Okay, IRDA supports point-to-point and point-to-multi-point communication, provided all devices involved in the communication are within the line of sight. Okay, whichever devices you're going to communicate, it should be within the line of sight. The typical communication range for IRDA lies in the range of 10 centimeter to 1 meter. The range maximum, it is wireless, as I told you, wireless communication. The range of communication can be maximum from 10 centimeter to 1 meter, not beyond that. It supports data ranging from 9600 bits per second to 16 Mbps. Depending on the speed of the data transmission, IR has been classified into different types. That is serial data, SIR, next medium IR transmission, next fast IR, very fast IR, and ultra fast IR, depending on the data transmission rate. Okay. So basically what it involves, if you just consider an example of your TV remote, it follows IRDA communication, right? And the remote section, if you observe, you'll have a small LED, right? IRDA communication involves a transmitter unit for transmitting the data over the IR and a receiver unit. So basically this transmitter unit is nothing but an LED, okay, as a IR source for transmitter, and at the receiving end basically a photodiode is used which receives that LED signals. So based on that, based on the frequency of the receiving and applications will run various different buttons, whichever you press, it generates various signals at different frequency. Accordingly, you can observe, if you consider the television accordingly, the volume may increase or the channel may change, depends on whichever button you're going to press, right? So the next type of communication, it is again from device to device. It is nothing but the Wi-Fi communication, and it follows IEEE 802.11 standard. Okay, Wi-Fi is intended for network communication and it supports internet protocol based communication. Based on the IP internet protocol, this communication will take place. It requires an intermediate agent called Wi-Fi router, Wi-Fi access points to manage the communication, right? In order to communicate from one device to device, I require an intermediate, we call it as a Wi-Fi router. It follows IP protocol, right? Wi-Fi router is responsible for restricting the access to the network because each router will have its own IP address, right? Whenever we need to communicate through that IP address, you're going to communicate the IP address to the device on the network. Routing data packets to the intended device on the net. It is based on the IP address, the data packets will be routed to the required devices. So basically it contains a wireless adapter for transmitting and receiving the data in the form of a radio signals. So Wi-Fi operates at different frequency, that is 2.4 gigahertz or 5 gigahertz of the radio spectrum, and they coexist with other ISM band devices like Bluetooth and all, right? So basically you can observe this is a Wi-Fi router which can be connected to various devices, and through these devices you can communicate from devices to devices through the router, right? Device will have its own ID as well as this router will have its own ID. So we call it as a destination ID as well as source ID. Based on that, the package will be transferred. So the next type of communication, it is nothing but the last type of communication, external communication. It is ZigBee. It is low power, low cost wireless network communication protocol based on IEEE 802.15.4 2006. It is a standard given. ZigBee is targeted basically for the low power, okay, low power transmission as well as low data rate and secure applications for wireless personal area network. Personal area network in the sense, say for example, if we consider a smart home system, smart home where sitting at a particular place you want to control, you want to turn on a particular device or turn off a device, or you want to monitor something. So such type of applications where a low power device is required as well as a low data rate is sufficient for us for the communication. So in such type of application, the ZigBee will be used. So basically, this ZigBee specification supports a robot mesh network, right? Mesh type of network it supports. It can, through a particular device, various mesh networks can be connected. This networking strategies makes the network reliable by permitting messages to travel through a number of different paths to from one node to the another. So it also operates at various frequency like 2.4 gigahertz to 2.4 to 2.484 gigahertz, or 902 to 928 megahertz, or 268.2 to 268.6 megahertz. At different frequencies, these particular devices can operate. And the operating distance can, there is a wireless communication, it can have a maximum distance of 100 meters and a data rate of 20 to 250 kbps, right? So basically, if we consider the architecture of this ZigBee, here also we have different components like, so you can observe here, main components, what we call ZigBee coordinator, ZC. Okay, we can consider it as a host of a system. We call it a ZigBee coordinator or network coordinator. The ZigBee coordinator, it acts as a root for the ZigBee network. Okay, it is responsible for initiating the ZigBee network, and it has capability to store the information about the network, like how many devices have been connected, which devices requires the communication, how the communication is done. Everything will be coordinated through this network coordinator or the ZigBee coordinator. Okay, through this ZigBee coordinator, various routers will be connected. We call it as a ZigBee routers. Okay, responsible, which basically it is used for, as you know that the distance of this communication is very short. Through this ZigBee router, what we can do is we can increase this communication length, or what we call the length of communication. For passing the information from device to other device, we may require this router. ZED is nothing but ZigBee end devices. Okay, so this end device contains nothing but the various devices where you are supposed to transfer the data. So end device containing ZigBee functionality for the data communication. It can talk only with, it can communicate only with ZR, that is router, as well as ZC, and doesn't have the capability to communicate from ZDD to ZED. Okay, it has to communicate, the communication should be done through ZR as well as ZC. Okay, which acts as a mediator for transferring the data from one device to the other device. So these are the different types of communications what we have in order to have a communication from embedded system from one particular device to the external device to the other devices.